Every year, thousands of men pack up their lives, cash out their savings, and head to Alaska chasing a dream. A log cabin, off the grid free, and every year, most of them lose everything, not to bears, not to blizzards, not to starvation. The very thing they built their dream out of slowly, silently destroys it. And by the time they see it happening, it's already too late. Today, you're going to find out exactly why log cabins fail in Alaska, what's really happening inside those walls that nobody talks about, and what the smartest builders in the state are doing instead. This is an opinion. This is hard-earned, frostbitten, wallet-emptying experience from the men who've lived it. Stay with me, because around the halfway point, I'm going to show you something about log cabin insulation that will completely change how you think about wilderness living. Most people have no idea, and that ignorance cost them decades of their life. Let's get into it. Alaska is not like anywhere else on Earth. People hear cold, and they think they understand. They don't. They think about a rough winter in Minnesota or a bad freeze in Montana. That's not Alaska. That's a polite inconvenience compared to what the Alaskan interior throws at you. In Fairbanks, temperatures regularly hit minus 50 degrees Fahrenheit. Not wind chill, actual air temperature, minus 50. At that point, exposed skin freezes in under 2 minutes. Diesel fuel gels. Tires go flat from the cold alone. And wood, the beautiful, rustic, romantic wood of your dream cabin, begins a war with physics that it was never designed to win. Here's what almost nobody tells you before you build. Wood is not a solid material. It looks solid. It feels solid. But at the microscopic level, wood is a network of tiny tubes, cells that once carried water and nutrients up through a living tree. When that tree is cut, milled, and stacked into a cabin wall, those tubes don't disappear. They're still there, waiting. And in Alaska, they become the enemy. During the brief Alaskan summer, moisture from rain, snowmelt, and humidity seeps into those microscopic channels. The wood absorbs the way a sponge absorbs water, slowly, invisibly, completely. Nobody sees it happening. The cabin looks fine. It looks great, actually. Solid logs, tight joints, beautiful grain. Then winter comes, and that moisture, trapped deep inside the wood fiber, freezes. Water expands by approximately 9% when it turns to ice. Inside a log, that expansion has nowhere to go, so it pushes outward. It forces the wood fibers apart. It creates microscopic cracks that weren't there before. The log doesn't shatter. It doesn't collapse. It just gets a little weaker, a little more porous, a little more open to the next round of moisture in the spring. Then it happens again, and again, and again. This process is called freeze-thaw cycling, and is a silent killer of every untreated, improperly sealed log cabin in the Alaskan wilderness. After 5 cycles, you have visible surface cracking. After 10, water is getting deep into the structural core. After 15, you have rot. And rot in Alaska doesn't smell like rot in Georgia. By the time you detect it in freezing temperatures, it has already hollowed out your walls from the inside. Men have walked out to their cabins in the spring, pressed a finger against a log that looked completely normal from the outside, and pushed straight through it, like wet cardboard. The entire structural integrity of the wall, gone. And they had no idea. That's the first mistake. But it's not even the worst one. Let's talk about the ground. Most men who build in Alaska come from the lower 48. They understand foundations. Concrete, gravel beds, frost lines. They built sheds, garages, additions. They think they know what a foundation is. They don't know what permafrost is. Not really. Permafrost is ground that has been frozen continuously, in some areas for thousands of years. It's not just frozen dirt. It's a complex, layered system of ice, soil, and organic material that behaves like a solid until it doesn't. Here's the problem. When you build a cabin, you generate heat. That heat conducts downward through your floor, through your foundation, and into the ground below. In the lower 48, that's fine. The ground absorbs it. Nothing dramatic happens. In Alaska, that heat begins to thaw the permafrost directly beneath your structure. And thawing permafrost doesn't just get soft. It liquefies. The ice that was holding the soil together melts, and suddenly you have a slurry of mud and water where solid ground used to be. Your foundation, no matter how carefully you build it, begins to sink, not evenly, unevenly. One corner drops 2 inches. The other side stays put. Your cabin begins to rack and twist under its own weight. And when a log cabin racks, the carefully fitted joints between logs open up. Those gaps, sometimes less than a quarter inch, become the expressway for cold air, moisture, and eventually rot. This is why you see so many abandoned cabins in the Alaskan interior tilted at strange angles. They're not abandoned because the owners gave up on wilderness living. They're abandoned because the ground swallowed the foundation, and there was nothing anyone could do about it without spending more than the cabin was worth. Professional Alaskan builders know this. They've known it for decades, and the way they handle it will surprise you. They don't pour concrete. They use posts, either steel pilings driven deep below the permafrost layer or adjustable timber posts set on pad foundations, and they leave a deliberate air gap between the floor of the cabin and the ground below. That air gap serves 2 purposes. It allows cold air to circulate beneath the structure, keeping the permafrost frozen, and it allows the builder to physically adjust the posts with a wrench if one side begins to sink. It's not romantic. It doesn't look like the log cabin of your imagination, but the cabins built this way are still standing after 30 years. The ones built on traditional foundations aren't. Now let's talk about something that will genuinely shock you, because this is the part that almost every outsider gets completely wrong, and it's the part that Alaskan builders say costs people most money and the most misery. Log cabins are terrible insulators. Read that again. The thing you've been told is a rugged, warm, off-grid shelter is, from an energy standpoint, one of the worst materials you could possibly choose for extreme cold weather construction. Here's the science. Insulation is measured in R value, resistance to heat flow. The higher the R value, the better the insulation. A typical exterior wall in a modern cold climate home is built to somewhere between R20 and R40. A log, a solid, beautiful, handcrafted log, has an R value of approximately 1 per inch of thickness. Most log cabins use logs between 8 and 12 inches in diameter. That means your entire wall, the wall you're depending on to keep you alive in -40 temperatures, has an R value of somewhere between 8 and 12. That is catastrophically low. A single layer of modern spray foam insulation in a properly framed wall outperforms your entire log wall by a factor of 3 or 4. And in Alaskan winters, that gap doesn't just cost you comfort, it costs you survival. Men running with stoves around the clock, burning through 2 to 3 cords a month, barely keeping indoor temperatures above freezing. Not because their stove isn't powerful enough, but because their walls are bleeding heat into void as fast as a stove can produce it. And here's where it gets worse. Logs also have something called thermal mass, which sounds like a benefit, but operates on a cruel delay. In moderate climates, thermal mass works in your favor. The logs absorb daytime heat and release it slowly at night. But in Alaska, where temperatures can stay at -40 for weeks at a time with no warm-up period, there's no daytime heat to absorb. The thermal mass just becomes a giant block of material that stays cold, conducts heat outward continuously, and contributes to condensation on the interior wall surface. That condensation freezes at night and thaws in the afternoon. On the interior, inside your cabin, ice on your interior walls, moisture running down your logs, mold beginning to form in the chinking between logs, a slow, grinding, invisible destruction of everything you built. This is not a fringe case. This is a standard experience for men who build traditional log cabins in the Alaskan interior without understanding the thermal physics involved. Let's talk about chinking. Chinking is a material used to fill the gaps between logs, the mortar-like substance that creates a weather seal along every horizontal joint in your cabin wall. Traditional chinking was made from moss, mud, horsehair, and whatever else was available. Modern chinking is an engineered synthetic compound designed to flex with the natural movement of the logs. And it still fails in Alaska. Here's why. Logs are not dimensionally stable. They continue to shrink, swell, twist, and move for years after they're cut and stacked. In a temperate climate, this movement is modest and manageable. Chinking can flex with it. Seals hold. In Alaska, the temperature swings are extreme. We're talking about a building material going from -50 in January to +80 in July, a swing of 130 degrees Fahrenheit. No material expands and contracts gracefully across that range indefinitely. Eventually, the chinking cracks, the seal fails, and cold air at -40 begins infiltrating your wall cavity at every joint simultaneously. Men have described sitting inside their cabins in deep winter, holding a lit candle near the base of the wall, and watching the flame bend sideways, pulled by the air rushing in through failed, chinking joints. Cold air that is invisible to the eye, but absolutely devastating to body and the heating system. Proper maintenance of chinking in an Alaskan log cabin means inspection every single year, and reapplication in sections every 2 to 3 years indefinitely. It is not a one-time job. It is an ongoing, expensive, labor-intensive commitment that nobody talks about when they're selling you the dream of off-grid wilderness living. So what are the best builders in Alaska actually using? The answer is structural insulated panels, SIPs. And if you haven't heard of them, pay attention, because this technology is genuinely one of the most significant developments in cold climate construction of the last 30 years. A SIP is a sandwich panel. 2 rigid faces, usually oriented strand board, bonded to a solid core of expanded polystyrene foam. No air gaps, no framing cavities, no thermal bridging. Just a continuous monolithic wall of insulating foam encased in structural sheathing. A typical SIP wall panel delivers R values between R14 and R28 depending on thickness, with no thermal bridging, meaning there are no studs or framing members creating cold pathways through the wall. Compare that to a log wall at R8 to R12, and the performance difference is staggering. But the real advantage of SIPs in Alaska isn't just the insulation value. It's the air tightness. Because a SIP wall is a single solid panel rather than a frame cavity, there are virtually no pathways for air infiltration. The panels are joined at the seams with expanding foam sealant and structural splines. The result is a wall system that is dramatically more airtight than any log construction, and in extreme cold, air tightness is the single most important factor in keeping a building warm and keeping its occupants alive. SIP structures built in Alaska by experienced contractors are routinely achieving whole building R values that would require 3 times the heating fuel in a comparable log structure. Men living in SIP cabins in the interior are heating their homes with a fraction of wood, or in many cases, switching to small propane systems that would be completely inadequate in a log cabin. Your logs must be properly dried before construction. Green logs, freshly cut wood with high moisture content, will move aggressively as they dry in place. That movement opens joints. It breaks seals. It creates exactly the kind of air infiltration pathways that will slowly destroy your thermal envelope. Properly dried logs, seasoned for at minimum 1 full year under cover before construction, move far less and produce a dramatically more stable final structure. Your roof overhang is not aesthetic. It is structural protection. The single most effective thing you can do to extend the life of a log wall is keep water off it. A properly designed Alaskan log cabin has roof overhangs of at least 24 to 36 inches on all sides. That overhang keeps the majority of rain and snowmelt from running down the face of the wall, dramatically reducing the moisture load that the logs must manage. Many of the most deteriorated log cabins in Alaska were built with minimal overhangs because the builder was copying a style they saw in a magazine, a style designed for a completely different climate. Seal aggressively and seal on schedule. A quality penetrating oil-based log sealant, applied to all exposed log surfaces before construction and reapplied every 2 to 3 years thereafter, is the most cost-effective maintenance investment you can make in a log structure. It doesn't eliminate moisture absorption, but it reduces it dramatically. And that reduction, compounded over 15 or 20 years, is the difference between a cabin that ages gracefully and one that rots from the inside out while you're still living in it. Elevate your structure. Leave an air gap between your bottom log course and the ground, a minimum of 18 inches. More is better. That gap keeps ground moisture from wicking up into your lowest logs, which are always the first to rot, and allows air circulation that prevents the chronic dampness that accelerates decay. There's a reason that the most experienced builders in Alaska, the men who have been at this for 30 and 40 years, who have built dozens of structures and watched all of them interact with the climate over decades, have largely moved away from traditional log construction. It's not because logs aren't beautiful. They are. It's not because the tradition isn't worth preserving. It is. It's because they have watched too many good men put their life savings, their retirement, their dreams into a structure that the Alaskan climate was going to dismantle. And they have spent too many years being called in to perform repairs that cost more than the original build. The Alaska mistake is not wanting to live in a log cabin. The dream itself is not the problem. The mistake is assuming that because something looks solid, it is solid. The mistake is assuming that because something has been done for generations, it is the right way to do it now. The mistake is building for the image of Alaska rather than for the reality of it. Alaska is the most beautiful place most men will ever set foot in. It will also test every decision you make with severity that has no parallel in the lower 48. The men who thrive there long term are not the ones who arrived with the most romantic vision. They are the ones who are willing to learn the hard lessons, preferably from someone else's experience rather than their own. Now you have them. Build smart. Build for the climate. Build to last. Because out there, the cold doesn't care how much you love your cabin, and it never forgives a mistake.